There we go.
Welcome to the Berkeley Climate Change Podcast. I'm Bruce Riordan. I'm the director of the BCCN. And our special expert guest today is climate scientist Daniel Swain. Daniel is affiliated with UCANR, Agriculture and Natural Resources. He's based out of Boulder these days. His work focuses mostly on the dynamics and impacts of extreme events, floods, heat waves, extreme storms, and all in our hotter world. You can follow Daniel at Weather West at his blog or on YouTube. Last year, Time Magazine named Daniel one of its 100 emerging leaders globally. So we have a great expert here, and we're going to talk weather and climate right now for about an hour. So welcome, Daniel.
Thanks for having me. And it is for better or for worse. It's relatively easy to get me to talk about weather and climate for an hour.
Great. Well, let's start with what just happened in March. You've written about it and talked about it, but this was over the whole West and very, not just record setting, but kind of record smashing. So tell us what happened in March in the West and why.
Yes, as we record this, we really have just lived through what has statistically and meteorologically been one of the most extreme heat events that's ever occurred in this part of North America. And that might sound a little bit odd to some folks because, of course, we've had, midsummer heat waves, July, August heat waves that have been hotter than the temperatures we just experienced, of course. But what I'm really referring to is the departure from seasonal normal conditions. So just how seasonally anomalous was this extreme heat event? And the answer is there's never been an event in all of recorded history going back over a century in a multi-state region, including all of California and most of the rest of the Southwest and even parts of the central US, where the departure from the typical monthly temperatures was so large as it was over the past month. So that is to say, yes, this past March was record shattering, not just record breaking, but in a statistical sense, record shattering because it broke previous records by absurd, enormous margins. That's not exactly a technical term, but it just gives a sense
Mhm.
that this was not just a little bit unusual. This was kind of shocking, and the irony of it is that the shockingness is actually the shockingly pleasant weather in some ways. Some people in California probably said this was the nicest March that's ever happened in recorded history. And that is one way to think about it, especially if maybe you were on the beach where it was 75 to 80 degrees every day in March and clear. That might literally have been the case. But there are broader implications, of a period like that, especially when it comes to the snowpack, which now in general, throughout the American West, is essentially the worst it's ever been in early April, and in some places by a wide margin, particularly the Colorado River Basin, which already was facing some big time problems. And in California, I believe the official number yesterday on April 1st, ironically, while it was snowing, they did the snow survey where there's essentially no accumulation on the ground, but it was falling from the sky while they stood there, mocking up the snow survey with nothing to show for it. I think it's ranked second lowest snowpack on record, essentially tied with 2015 for the lowest. So there were, big time consequences. We're effectively 2 months ahead in a lot of the West in terms of mountain snowpack and runoff and soil moisture conditions. It's not a disaster in and of itself right now, but it's one of those things that kind of portends maybe a difficult summer ahead in some places. So it's one of those things that makes those of us who look ahead to the next season and the next the chain of events that can lead up from one seasonally anomalous event makes some of us a bit nervous, but certainly a historic event by any metric.
And Daniel, before we kind of look ahead, talk a little more about this. You, I think, wrote that the size of this geographically, this wasn't just California or just the Southwest, but extended with record temperatures all the way into the central part of the U.S. Correct?
Yes, this was the warmest March on record, and in particular the hottest March heat wave on record uh, for at least a few days to a week across a significant portion of the lower 48 U.S. states. So really extending all the way from the Pacific coast in California eastward, east of the Mississippi River. So this was not just a Western U.S. thing. It wasn't just a Southwestern U.S. thing, but I think almost every U.S. state broke at least a few daily temperature records in March, and much more notably, about a third to half of all U.S. states saw their warmest March temperature on any date ever observed. I think the most striking kind of statistic comes from places actually like the Bay Area and places in Southern California and Arizona and some other true Western states west of the Rocky Mountains, where temperatures this March, especially the average March temperature, in fact, was so warm that it was not only the warmest March on record, but it was actually warmer than the warmest April on record and in the top three warmest Mays ever recorded. So you're working against the calendar. You know, this is even more extraordinary than it would have been the case if we had something in September had been warmer than the warmest Novembers and Decembers. There, the calendar's working, it's getting cooler as you go forward. Here, it's you know, breaking, the records we broke by such margins put us into record April territory and near record May territory. And just as somebody who studies weather and climate pretty closely, I mean, it's just kind of astonishing to break records by that margin. So clearly this was an extreme outlier event, even relative to the rapidly warming climate that we're currently living in.
Now, at the same time, here in California, at least, it was one of the driest, if not the driest, in terms of precipitation for March. Uh, was that a part of the same kind of system that we're going to talk about here that caused this, or?
Yeah, in a proximal sense, yes. I mean, we had essentially this big ridge, this unusually thick layer of atmosphere. Essentially, it's thicker because it's warmer and it's sort of chicken or egg. But you have a thicker, warmer lower half of the atmosphere that redirects the storm track, which then perpetuates the ridge and allows it to warm up more, allows it to persist. So there's some self-reinforcing feedbacks built into this. But we have this big persistent, record-breaking, record-shattering, really, ridge. All the metrics we use to quantify the physical size and the magnitude and the depth of high pressure ridges in the middle atmosphere were at record-shattering levels for most of March, frankly. And yes, it's the same thing that produced the really warm temperatures locally and then also redirected the storm track. Notably, it really did redirect the storm track. It didn't dissipate it. Washington and British Columbia were extremely wet in March. They actually had flooding and in the mountains, extremely heavy snowfall. So, when you have one extreme in one spot, you often have kind of an opposite extreme in some adjacent region. Doesn't mean they're equal and opposite. In a warming climate, they almost never are. The warms are almost relatively warmer than the colds are, but you still have pockets of relative cold and relative wetness adjacent to relative warmth and relative dryness, and that's certainly what we saw across the much of the western United States, minus Washington State versus Washington State and British Columbia during March. But it was just a remarkably persistent pattern. The other thing too is that this winter was a little drier than average in parts of Northern California, but not exceptionally so. We've seen much drier winters even in the past decade in Northern California and in Southern California. The winter ended up much wetter than average, even on the heels of what was actually a record wet start to the season. So there's never been a wetter start to any water year on record in places like Santa Barbara and Ventura and Los Angeles counties. So October through December 25 were not only wetter than usual, but in fact were the single wettest period in well over a century of record keeping. So we've really seen yet another season that's characterized by pretty extreme swings, both between Northern and Southern California, and just from month to month within the wet season, where we've actually had some periods and locations in the state that experienced record wet conditions this water year. Almost all locations in California experienced record warm conditions this water year because we had a record warm winter in most places, even preceding this then record shattering event in March. Even if that hadn't happened, the winter itself would have been record warm in a lot of spots. And we started the season, really active. And so, even in February, which was not an extremely wet month overall, we had some very impressive Sierra Nevada snowstorms. We had one of the most intense 1 to 3 day snowfalls we've seen in the recorded record. Not number one, but it was in the top five in some areas for single storm accumulations, which managed to melt within 3 or 4 days of having 3 or 4 feet of snowfall. Rather than becoming snowpack, it just kind of poofed away amid a really warm and then moist and then later warm and dry air mass. So the operative word, really, we've seen everything under the sun in terms of wet and dry on the hydroclimate spectrum this winter, but the one thing we haven't seen is extreme cold. It's just been warm, warm, warm all winter long.
Yeah. How about ocean temperatures? Also, I saw something more Southern California, maybe more than North, but Pacific Ocean temperatures are pretty high right now.
Yes, the nearshore waters and really the well offshore waters too. So at this point, it doesn't matter where we look. It's warmer than average virtually everywhere along the west coast of North America. But you're right, it does get relatively more anomalously warm as you go south. And if you get south of about Point Conception, so the Southern California bight, the most of the water right off the highly populated Southern California metros, so LA County, San Diego County, Orange County, is really experiencing what you could characterize as an extreme marine heat wave now for weeks or months. Ocean temperatures are record breaking at the Scripps Pier, so we've never seen water temperatures at the surface this warm this time of year. In fact, like the air temperature above them, for much of March, the Scripps Pier temperatures have been so warm that they would have broken records all the way out to June for the water temperature. So, you know, we're really sort of at the upper end of the observed distribution, or in many cases, well outside of it right now, and by any number of metrics.
What can we say before we look ahead to the summer and all? What can we say about climate and the hotter planet and this kind of an event or big event that we had in record-shattering events, plural, that we've just gone through in March?
I think we can pretty definitively say that it absolutely played a role in making the event as extreme and as warm and as consequential as it was, and we can also pretty definitively say that it isn't the only factor that made it so. If we don't include the effect of climate change, we're missing a big part of the picture. But if we say, if we only look to climate change for the explanation, then we're also missing a big part of what's going on. And, when it comes to any, record-shattering event anywhere in the world, whether it's related to temperature or anything else, these days it's almost a trivial statement to say that climate change made the extreme heat event more likely and more intense. It's almost scientifically uninteresting because it's so obviously true. It would be essentially impossible to run a study and then find at this point that the answer was not statistically significant. But maybe the more interesting question is, the matter of degrees, literally, to what extent? And I think this is where there is some genuine uncertainty. And there's some rapid attribution studies that have come out and actually pointed to a pretty large increment for this event, something like 5 to 7 degrees Fahrenheit on a multi-week basis, which is actually quite a lot, in particular because it's more than the mean warming in this region during this time of year. And yet, I still think my professional hypothesis is this is actually a fairly conservative estimate, even then, as to the magnitude of the role. And that's partly because there are some processes, some feedbacks. When we get to really extreme heat waves, there are some self-reinforcing properties that climate models by design are not necessarily great at capturing. So what do we use for these rapid attribution studies? Well, we use these global climate models, these large ensemble simulations, and they're not always fully suited to capturing the nuances and the tails of the distribution. So they're good enough to give us the sign, SIGN, of the answer, that clearly climate change played a role and to a substantial degree, but the exact magnitude of it is, I think, a little bit harder to pin down. And I think we saw this with other recent record-shattering heat waves. We think back to the June 2021 event in the Pacific Northwest, that astonishing event where it got to 116 degrees in Portland, Oregon, well above any number they've seen in recorded history. Seattle, I believe, was 108. The glacial valleys of British Columbia got up to 120 degrees Fahrenheit. I mean, really, really just phenomenally extreme heat. We are lucky, by the way, that this event in March in California was not a June event because had it done so, had a similar anomalously extreme event occurred in June, we would have had a 2021 like impacts or worse locally. But in that event, the science that's been done, now that it's been a few years, we actually have some solid depth of literature to refer to. It's not just the linear increment that matters. Yes, there's sort of a raising the floor effect where, all heat waves are at least a few degrees more intense because all temperatures are a few degrees warmer than they would have been because there's some shift in the mean of the temperature distribution. But then in that event, there are actually very large aggravating factors that are not explained by the mean shift. One of which, in that case, was soil moisture feedback. So you have dry soil, you have a heat wave, it lasts a long time, it starts to dry out the soil even more. An increasing fraction of the sun's incoming energy is going to heating the soil and therefore the land surface and the air above it rather than evaporating water. And then that's a feedback too, because the more intense the heat wave becomes, the more water it evaporates, the more of the energy that goes into heating the air, et cetera, et cetera. There's a climate change contribution there potentially because we know that it's easier to get soil water deficits faster in a thirstier atmosphere with a higher vapor pressure deficit, greater evaporative demand. But I think some people probably have heard of that piece. The one I thought is really fascinating, this is really an emerging topic of discussion, in particular because I think it also probably has relevance for what we just experienced in March directly in California, is this notion that moist feedbacks also can amplify heat waves. So it isn't just that dry begets hotter, which can be true in certain events. I don't think that was as relevant with this March event because the soil was still relatively, it is March after all. There's still some snow in the mountains. At least there was in the beginning. But this other piece, where latent heat release in the atmosphere in some place that can be quite distant from the region of the heat wave. So in the case of this March heat wave affecting California and the Southwest, I think there's probably a significant role for latent heat release upstream near Hawaii. So you may recall that this month there's been record-breaking rainfall and severe flooding on the Hawaiian Islands, and of course, it's more broadly in the Central Pacific. There's been a lot of rain and a lot of condensation and latent heat release in a record moist atmosphere with record warm water temperatures. The conversion of higher energy water vapor to lower energy condensed water in a cloud, that represents a profound release of energy. And when it happens for days and days on end in a concentrated place with a wind pattern, in this case, an atmospheric river that was essentially piping that energetic air mass directly into the Pacific Northwest, where it was rotating right into this ridge. That's very similar to a mechanism that was identified in retrospect in 2021 as being a dominant factor in why that event was so extreme. Something like 30 to 60% of the intensity of the whole event was attributable to that latent heat release from an upstream atmospheric river over the Pacific. So, in this indirect way, that's another potential way that climate change could contribute because, of course, we know there is more water vapor in the atmosphere when it is saturated in a warming climate. Not all the time, but when it is precipitating, when you're in a cloud, when you're over a warm ocean basin, you have more water vapor for a given degree of warming. So I know it's a little bit technical. That's getting really into the meteorology of it, but it's a fascinating case where we have these estimates, these rapid attribution estimates of, this heat wave was, 4 to 7 degrees Fahrenheit more intense due to climate change. And I think, as a baseline, I think that works fine. But in my mind, I'm kind of thinking of it a little bit as a floor because I don't think that things like soil moisture feedbacks or upstream latent heat releases that induce this persistent blocking or the increased adiabatic descent temperature of the air mass, all of these things that sound very esoteric and technical actually end up being pretty profoundly fundamentally important in these sorts of events. So just an example of how, um, there's plenty of science left to do in the climate world and in atmospheric science in general.
Well, this is a great picture of what's been happening recently here in California and in the West. Let's look ahead. This spring, this summer, we hear El Nino building. I know you can't totally project the future, but what are your thoughts on maybe what we're headed towards here in the spring and summer?
Yeah, this is an interesting year, and I sort of have grown up in the West, personally and professionally in this era where sort of El Nino has entered the public consciousness. I remember, the big event in 97, 98, and how rainy and how stormy it was, growing up in California. And then more recently, some of the more significant El Nino events that did not produce as extreme of effects as did the early 80s event or the mid 90s event in California. And what's interesting to me is that sometimes scientists, I'll go out on a limb and say, who should know better than to draw strong inferences from a statistical sample of just two or three events, have said, oh, well, actually, this influence of El Nino is overblown. As we can see from the last two events, it really isn't that important or that predictive of California precipitation. I do not buy that for a second.
Hmm.
And the important thing to emphasize is if all we had to go on were historical observations, then I understand where that skepticism would come from because we've essentially had in the last 20 or 30 years, or I guess in the last 40 years at this point, we've kind of had two very strong El Nino events that were very wet in most of California, and two that were not, one of which was actually fairly dry. If that's all we had to go on, then I would agree that that doesn't tell us very much. But that's not actually all we have to go on scientifically. We have process-based understanding of what El Nino is, what El Nino does, and we actually have far more than a sample of four or five events in synthetic simulations, essentially. We have large ensemble climate simulations where we run these coupled ocean atmosphere models over and over and over again for hundreds of simulated years, dozens of iterations each. Have four or five big El Nino events. We have dozens to hundreds of them. And all of the physical science on this really does suggest that once you get into strong or very strong El Nino territory, that it is probably the single most reliable predictor of southwestern hydroclimate that exists. And paleoclimate studies, these indirect proxy inferences from past climate, they also support the claim that the ENSO warm events, the El Nino Southern Oscillation, ENSO being the broader acronym for the process we're talking about, is pretty profoundly important for southwestern hydroclimate. So all of that said, I do think it's always true that El Nino is knowing the state of ENSO or El Nino is not enough to know exactly what's going to happen. It's never perfectly predictive or prescriptive or determinative. It's but one factor, but it is probably the single most important factor in terms of interannual variability, and maybe the most important piece, it's the factor we can predict the best in advance. We actually do have some ability to predict the sequence of ENSO 3, 6, even 9 months out to varying degrees under varying circumstances. We don't really have the ability to do that for a lot of other sub-seasonal to seasonal kind of uh, oscillations that we know are important. We know where the climate change is headed in the long run, but that only really helps us over multiple decades. It doesn't really tell us much about this year versus next year. But ENSO and El Nino can. And there are sort of these windows of opportunity, I would say, where the outlet gives us some potential real insight about the future, and some cases where it doesn't. If we
Hmm.
were talking about a potential for a weak, maybe even a moderate event, I'm not sure it would tell us very much because it's so much in competition with other factors at that level of intensity that it's kind of a wash whether it ends up being the dominant factor or not. But this year, there are strong signs right now, as of early April, that we probably are headed for an El Nino event of significance.
Hmm.
And I'm comfortable saying that now. Exactly how strong it gets, I don't know. But right now, the best predictive models we have suggest that it could be one of the strongest events we've ever observed. And that's a pretty bold prediction from a multi-model ensemble average to predict something that is essentially the highest value for various ENSO metrics we've ever seen. So I'm not going to necessarily commit to that kind of extreme forecast, but right now, El Nino looks very likely this year, and the odds of a particularly strong one are especially elevated. And given that, it does, I think, open the door to some questions about what might happen this summer and beyond, because a particularly strong event does have real implications for California and the Southwest. Probably means our coastal water temperatures are going to stay elevated for the foreseeable future. So that marine heat wave we've got in place right now is probably not going to go anywhere, especially for central and southern California. So that may be with us well through the summer and into the fall and beyond. That probably means less persistent coastal fog this year. So we've actually had a few years recently where the coastal fog was really pronounced,
Mhm.
especially in May and June. It was pretty chilly along the coast. I don't think that's likely to repeat itself this year. So that will be noticeably different if you're in fog-prone parts of the Bay Area or Southern California. Um, and then I think this summer, it certainly elevates baseline temperatures. It doesn't necessarily increase the likelihood of extreme heat waves, but it makes it much more difficult for things to cool down. So it makes those overnight temperatures considerably warmer, not just along the coast, but even well inland. So we might see much warmer than average spring and summer, not committing to extreme heat waves necessarily, but just because the baseline might be so elevated. Get rid of those cooler days, those foggier days. And then later in the summer, um, those really warm water temperatures off the coast of Baja California mean that the possibility that California sees the remnants of some tropical systems, which is kind of unusual, does go up in years like this one. So that could be a blessing or a curse. It could be like 2022, where largely that was a beneficial event when the remnants of Tropical Storm Hillary dropped several inches of rain in August in Southern California and pretty much short-circuited the rest of fire season. There really wasn't a fire season during Santa Ana wind season that year, which was kind of a nice for a break. But compare that to September of 2020, or I'm trying to remember when that dry lightning event was in the Bay Area, if it was
Mm.
either late August or early September.
Hundreds of strikes, yes.
And that also was the remnants of a tropical storm, in that case, Tropical Storm Fausto, that had the sort of the opposite effect, where it really kicked a terrible fire season into high gear. Now, this year we kind of have intermediate risk conditions where we're not in a severe multi-year drought like we were in 2020. So we don't have those preconditions in place. That's good. But as we've been talking about, we did have a record warm winter and then a record shatteringly warm March. And so in mountain areas that would normally have a significant snowpack and do not, they're probably looking at a more active fire season this year. And in some parts of Northern California, where this winter really wasn't particularly wet, but it was very warm, we might see an earlier start to fire season in some of those settings as well. So looking like, El Nino, and that's just, up through the late fall, the late summer and early fall months. If we really do get a big El Nino event, next winter is really where the rubber meets the road in terms of potential impacts. And it could be good news, it could actually be helpful in the desert Southwest and the Colorado Basin in particular in bringing some more robust precipitation where we desperately need it. It won't necessarily bring cooler conditions or incredible snowpack, but at this point, I think the Colorado Basin is going to take whatever water it can get. And if we do end up with a strong El Nino event, the odds that they'll get something that they need the latter half of this calendar year, at least, I think does go up.
It's April now. How soon will you know more surely what's going to happen this summer? Do you and El Nino forming and all? Is that really going to take, till June or July before we really understand? I'm thinking about preparation in cities for heat events or preparation for outdoor workers, farm workers and all. At one point, do we are we able to sound the alarm here?
Yeah, I mean, I think it depends sort of which kind of potential risk we're trying to mitigate. If it's extreme heat, as I mentioned, a strong El Nino event wouldn't necessarily increase the likelihood of really extreme daytime heat, but it actually might be uh, especially important for some of the heat that's more subtle, but is actually does matter a lot for urban heat risk and public health and outdoor worker type mitigations because it is that ba overnight minimum temperature not falling below a critical threshold that actually really is in some cases the greater stressor on the human body in places where people don't have access to air conditioning. Um, Elevated coastal humidity. I mean, when I lived on the west side of LA for a couple of years, that apartment did not have air conditioning, and normally that's fine. But that particular, pair of summers was kind of like this one, actually. It was during one of those last significant El Nino events where the coastal water temperatures were extremely warm, and we don't normally think of California as a hot and humid place. We think of it sometimes a warm and dry place, certainly. But places in coastal Southern California can get really humid. And the last time we had a major El Nino event, Los Angeles was getting as humid as Miami was with similar temperatures at times. And so, but of course, Miami is designed differently. It's built for humidity, and a lot of Southern California is not. And so, I think, we already have that marine heat wave. That's probably already something that we need to be thinking about in the big Southern California coastal cities. I think the other question is sort of in terms of wildfire, how do we plan differently for this year? And I think the main theme this year is that after a few really quiet years in the higher elevation forest, because it's been quite wet, this may be a different year. This may be a much more active year, particularly in the higher elevation locations where there would normally be snow right now and where there is almost none. And then looking ahead to next year, you know, the fall and winter to come, we're going to be really looking at the Colorado Basin water situation in particular. And if we do get to June, it looks like we're still going to have a big El Nino event. Hopefully, that will allow us a little more headroom on what otherwise might be pretty drastic decisions that are going to have to be made later this summer in terms of allocation of Colorado River water. So, as usual, the San Francisco Bay Area is a little bit insulated from some of these immediate short-term problems. There's no water supply crisis, in Northern California this year, and because there's multi-year drought resilience, no matter what happens the rest of this year, there won't be this year. That's a not even a very bold prediction on my part. And yet, snowpack will be at or near record low levels this spring. We've had a record warm winter, and so the analogs are different. There really isn't a water supply crisis in California right now, and yet wildfire risk might be considerably elevated. Ecosystems might be considerably out of whack, as will agriculture as well, because everything is a couple months ahead, and we are still in early April. So, I think sometimes it's easy to forget. I keep having to refer to the calendar based on the wardrobe. I've been just since January all throughout the West, Southern California and Colorado and Texas and all of these places, it's been 90 to 95 degrees when I've been there. And, these are not necessarily cold places, well, except for Colorado, maybe in the winter, but
Mhm.
so they certainly aren't places that are normally in the 90s in January, February, and March. And so this has sort of been this um, just this strange year.
Yeah. So, okay, that's the picture of what's happened and some ideas about going forward, at least this year. Let's move a little bit over to the side. You talk with scientists, I assume, a lot, and with policymakers. You're called on these days by the media, and I assume others in our state government and all to talk with them about what's happening. What do you hear over the last few years as these extreme events have become more numerous or more obvious, both here and elsewhere? Are you hearing a commensurate, interest in taking action or new climate policy or new resilience actions? What are you hearing?
I think it's a little bit of a mixed picture right now because it's such a difficult time politically, it's especially at the federal level, but that does, I think, cascade downward a bit to smaller scales of government too. Um, Really, right now, the weather and climate world, everyone is kind of scrambling, to be quite honest, because there has been such utter uh, decimation of some of the cornerstones of certainly of funding in the field, but even of institutional support for any number of endeavors. I mean, a lot of university research and federal government, lab and department research and operations is predicated on a certain level of stability and a certain level of federal funding that simply has just evaporated. And despite the fact that there was a successful effort to sort of try and get Congress to appropriate largely a flat amount of funding for a lot of these federal agencies in the most recent cycle, that money is not being paid out. And even as we speak this week, I'm having lots of emergency meetings with people whose funding and whose labs have just unexpectedly been defunded. Despite projects not being canceled, the checks, the bank transfers just aren't arriving. And so right now there's a little bit of triage going on across, I mean, at NCAR, the National Center for Atmospheric Research, at individual researchers, university labs, certainly within government agencies, although frankly, in a lot of those, we've already lost about 10,000 scientists from federal civil service since last February. So a lot of the challenge right now is there's it's a little bit difficult to be a little more proactive about some of this stuff right now because there's so much effort spent on sort of emergency response. And I mean, that's true both literally in terms of responding to disasters in some cases, but right now it's also trying to car circle the wagons in the research community too. I think in California, I think this is an interesting moment because there's a growing recognition that in addition to climate mitigation, which is solving the underlying problem of global warming by rapidly reducing and eventually zeroing out emissions. The challenge with this is that that is inherently a global problem. And no matter how much progress California makes, as important as it is for California to make that progress in the mitigation space, California cannot on its own solve the problem, even if California's emissions went to zero. California would still be experiencing climate change and the warming that's part of the bigger global problem. What has been, I think, an increasing recognition is that we also, in the meantime, need to be doing adaptation to a much greater degree than we have historically, even in California. In fact, California has long, I think, been a leader, I think it's fair to say, in mitigation of climate change. It's less clear that California has been so when it comes to climate adaptation. And there's actually a lot of empirical evidence that we are behind the curve right now in a bunch of different respects. And I think one example of this is what has transpired with wildfire in the past 15 or 20 years. We've seen this rapid escalation. Again, it's not only climate change that's causing this, but it is a large part of it, on the order of, I think, depending on how you define it, on the order of half of why this situation has escalated. So it would have been escalating anyway, but it's probably about twice the escalation that we would have experienced were it not for the changes in climate that have evolved at the same time. So we've seen a doubling or more of extreme fire conditions at multiple times of year. Uh, and I think we're seeing the consequences of not being circumspect enough, not being forward-looking enough with how quickly and how dramatically those risks could rise, how climate change could be a multiplier on other risk factors that were also relevant. And now we're trying to catch up. We're desperately trying to catch up. We're doing all these sorts of things. We're doing good things, and there has been real progress on any number of fronts in terms of community preparedness and emergency evacuations and and actual fire response, and then proactive measures like vegetation management and home hardening and all these sorts of things. There's been real progress towards those things, and yet we still saw the costliest fires in modern history just last year, despite some of these efforts. So it's an illustration of what happens when we're working the challenge, how hard it becomes when we're trying to catch up instead of being proactive. And my goal these days is to really not only help people to catch up in the wildfire space, that is part of what I'm doing, but also really getting people to think ahead to the next thing so that it's easier and cheaper and less disruptive to do some of that work now before the big bad thing happens in the space that we weren't thinking about. And one of those spaces, honestly, is with respect to flood risk. This is related to the Arc Storm 2.0 contingency planning scenario that we've been working on for years in California. This is the second iteration, by the way, of Arc Storm. There was an original version that was in the late 2000s, published around 2010. At the time, a lot of the folks who were originally involved with that project will tell you really talking about climate change was almost a non-starter, even in California, in government. It was essentially something that really, in that context of emergency response and flood risk, you really couldn't have that conversation. And I know that's surprising to some folks that circa 2010 that was still true. It is changing today, and the reception for Arcstorm 2.0 has been different. There's
Mhm.
still some skepticism. I still think that it requires circumspection that is difficult to require of people because it requires us to think beyond what we've recently observed. It requires us to think beyond the severe droughts, the historic wildfires that we have seen and that have wrought real consequences. But my point is the reason we need to do it is precisely because we haven't experienced it yet and we have an opportunity of unknown duration to get ahead of that curve. And so that's kind of the way I think about where the most important short-term work can be. Things like reducing community exposure to the risks from wildfire and larger scale societal risks to things like flood risks that we haven't thought about as much, but that we actually have a golden opportunity to get ahead of.
I worry about extreme heat here, and that extreme events help bring that out, unfortunately, to so people see it more clearly. But I here in the Bay Area, where a large portion of our population is not living with air conditioning, either home and or work. My campus up the street here,
Right.
a number of those buildings are not built for a climate during the spring or the fall when you would get these extreme heat events. So is heat, I guess, one of the things also that you'd like California to get ahead of the curve more on?
Yeah, I mean, absolutely. And, unfortunately, heat really is one of the deadliest weather events that's out there. It kills more people than any of the more visually dramatic storms or floods or hurricanes that are out there. I mean, it is the single deadliest type of weather event in the United States and in many countries in the world. And we undercount, we underestimate it in many ways because it is not, it usually, I certainly hope it's not bodies in the streets level visual. And I don't love the expression, but sometimes that is what it takes to really get people to notice things is a much more visual, heat waves don't destroy buildings, they don't wash out highways. They don't usually, unless you're in Phoenix on a really hot day, close down the airports.
Mhm.
But it does kill people. It does result in very large amounts of illness as well. It's not just deadly, but it is, you might recover, but you can become very ill. You can become seriously ill. And one of the challenges with heat risk is that sometimes it's excursions from the normal that are the most dangerous. So it's not necessarily the hottest places on average have the highest heat risk. I mean, obviously there is in some sense elevated heat risk, but people's individual human bodies are not adapted to heat if they live in a cooler place that occasionally gets extremely hot.
Yeah.
And as you mentioned, importantly, the infrastructure and the buildings specifically aren't built to accommodate it. When you get a hot event in the Arctic, for example, I mean the building insulation is usually it's there to keep the heat in when it's cold. But if it's hot, that you don't want to keep the heat in, and that's how the building is passively designed. And you might not have access to active cooling. And, in coastal California, it's still really uncommon to have air conditioning. And, that's true of a lot of the Bay Area. It's true of even a lot of, coastal Southern California. But as I mentioned, that is changing. If you ask HVAC installers, on the west side of Santa Monica or in the Bay Area, people are putting in, I would hope that they're preferentially putting in heat pumps these days, but some people are, putting in heat pumps or air conditioners or whatever, active cooling, whereas there really wouldn't have been much of a need
Yeah.
historically. And
Yep.
so, yes, this
Yeah.
is a real concern, and it affects people who both you either work outdoors or you don't have permanent housing and so are living outdoors and sort of exposed to whatever the weather's doing ambiently and people who live in places that don't have reliable cooling. So you live in an apartment building where you don't have either air conditioning or someone else controls access to the central air, and they're trying to be cheap with the controls, and it's not cool enough to be safe at night. This doesn't sound dramatic, but it actually is one of the most important things because it affects essentially everybody to some degree, and your level of exposure to it, depends on where you live, where you work, what your living arrangement is, but no one's really immune
No.
completely from it.
No one is immune, but yet it's such a justice issue here of separating into two categories, say even people with air conditioning and people without, or
Yeah, yeah. And
people who can't pay the bill for air conditioning
yes,
or have to
especially these
work
days.
outside. Yeah.
Yeah, and that's the thing is that, there's this I've heard this argument that air conditioning is immoral. I increasingly hear that, even from some folks in the climate world, and I just fundamentally disagree, in the sense that I understand that it can take a lot of energy to run a traditional air conditioner. That is true in a lot of parts of the world. A lot of the electricity that we use is still resulting in the emission of greenhouse gases because we're combusting fossil fuels to get there. But A, that's actually not universally true anymore in a lot of parts of the world. B, there are some very efficient ways to cool structures, either through passive construction or through things like heat pumps, which again are a really incredible tool in a place like California. They're super energy efficient, they work really well. But also, even if that weren't true, and even in parts of the world where we know it isn't true, I don't think it makes sense to say that individual people don't have to a safe physical environment, even if it means that you have to burn some fossil fuels to get people there. Ideally, we move toward a world where you don't need that,
Yeah,
where that negative externality of fossil fuel usage is not connected to having a safe indoor environment for humans. But where it is, I think it is very reasonable that people would want to attain that. I mean, I certainly would. I mean, I have a medical condition that makes it really difficult to thermoregulate. So I do not personally do very well in hot, humid, especially hot and humid environments, without access to air conditioning. And so that's just a reality that I personally have to deal with. And so I'm very cognizant of the privilege of having access to that air conditioning most of the time and how problematic it can be if you don't for whatever reason in whatever circumstance. So I'm all for active cooling,
mhm.
but we should be trying to make it, equitable and affordable and energy efficient to the greatest extent we possibly can, but not to the expense of actually giving people access to something that need to be safe.
Yeah, have to be. Thank you. Let's finish up here with talk to students directly here for our last little section. These podcasts are going to faculty and staff, but also to our student population. What's your message these days to uh, 18, 19, 20, 21-year-olds here at Berkeley and elsewhere where you've been working? What do you tell them about their future?
Yeah, it's a difficult moment, I think, in this country for so many reasons. And I think that a lot of people who are in college right now, or either are thinking of going to college or just graduated or in graduate school or even early career in science or whatever other discipline, sort of starting out in whatever career, I think are facing some serious headwinds, and I think that to claim otherwise would be clearly not an accurate assessment of the way the world is right now. But I think that for me, and I get very agitated by any number of things that are going on right now, and I'm fortunate to be able to channel a lot of that into constructive
Mhm.
work, where I just never stop working ever is kind of one of ways that I personally cope with that. Whether that's a good work-life balance is I will leave that to the reader to determine, but or the listener, I guess in this case. But I think that. My advice would be to channel whatever you're feeling right now into something that is constructive, and that can mean something very different for different people. But I think we're also sort of one of the silver linings of living through a tumultuous period is it's also a period where incremental shifts really can tip the balance of where things end up. So, because everything is moving so quickly and changing so rapidly, and so many people are not satisfied with the way things are right now, means it's a golden opportunity to do something about it and to be part of that process. So, I think that's sort of the way that I think about where we are right now, both in terms of climate change and politically and societally with everything going on. And I realize that may not be a fully satisfying answer because some people might say, well, gee, thanks. That's not very specific advice. But I think it really does depend where you are in your life and where you are geographically and sort of how you interact with the world. But I think that, you know, we people have asked me, how do you know exactly, how bad climate change is going to get, the consequences are going to be. How do you sleep at night? How do you even have a retirement account? Do you even bother? I'm like, of course I do. In fact, all of this means that I think much more carefully about planning for the future than I might otherwise. I actually think a lot about the future. So, sure, live in the present, live your life, but also I think please do imagine a better future because it is possible, but it won't happen spontaneously. And so, please also be engaged in helping us get there in whatever capacity you're able to right now. I certainly am trying to do that.
Well, thank you, Daniel. Thanks for taking some time with us here on the BCCN podcast. And thank you for your work over a number of years. We depend on you and others to help us push forward on the science. And thank you all for listening. This has been the Berkeley Climate Change Network podcast with climate scientist Daniel Swain. You can follow Daniel at, let's see, Weather West, yes, your blog, and also on you have a YouTube channel. Are there other ways, Instagram and all, they can follow you?
Yes, well, you hit the two key ones on the head. I'm at weatherwest.com, the Weather West blog, and Weather West on YouTube. I have a live weather and climate virtual office hours, essentially weekly. You can join me there, and maybe I'll answer your question. But yes, I also am on any number of other social websites. I'm on Blue Sky and Mastodon and Threads, and also X, formerly Twitter. I am still there, but so you can find me almost anywhere if your platform of choice.
Great. Thanks, Daniel. And thank you all for listening and stay tuned for other in the series of Berkeley Climate Change Network podcasts. Thanks.